Page 2. Page 2 is complex fractions. And in complex fractions, I'm looking to get one fraction on the top and one fraction on the bottom before I can simplify. So you first are going to have to do the addition or subtraction on the top and bottom before you can continue. So in this top problem, 3 over x, the common denominator is x. So I have to multiply the 2 over times x over x. So that becomes 3 minus 2x over x. Same thing here, I have to multiply by x over x. So that becomes 4x minus x over, my common denominator is 3. Here we do that. Going too fast here. Okay. Common denominator is 3, so I have to multiply by 3 over 3. So that makes this one, 3 times 4 is 12 minus x over my common denominator of 3. Now I am going to flip it, keep the first fraction as is, change it to multiplication, and flip the second fraction. Now, if at this point I could cancel something that was in common on the top and bottom, I would, but there is nothing in common on the top and bottom, so it's just going to stay my two binomials, 3 minus 2x and 12 minus x, and the 3 and the x. This one, I can leave the top alone. I don't do anything with the top yet because it is a single fraction, so I just need to get a single fraction here on the bottom. So that means I have to look at the opposite denominator. This one I'm going to multiply by x plus 5 over x plus 5. This one I'm going to multiply by x minus 4 over x minus 4. So I'm going to distribute the 2 to the x and the 5, so that becomes 2x plus 10. My denominator is going to be x plus 5 times x plus 4, x minus 4, excuse me. And then plus, distribute the 5 to the x and the negative 4, 5x minus 20. Now, I have a single on top and a single on the bottom. Let's go ahead and simplify before we rewrite this. So 2x plus 5x is 7x. 10 minus 20 is negative 10. And then x plus 5, x minus 4. Now you can flip the second one and turn it into multiplication. X plus 5, x minus 4, over 7x minus 10. And again, you notice they have an x minus 4 on the top and bottom, and I'm left with 3 and x plus 5 on top, and a 7x minus 10 on the bottom. And that's my final answer. Number 10, not really tricky, you just have to have a common denominator before you can add and subtract all of those. So notice my common denominator is x, so I need to multiply each of these by x before I can continue. So x times x is x squared, plus 6 times x is 6x, and I leave the minus 7 because it already has a denominator of x. Same thing here, x times x is x squared, 10 times x is 10x. I leave the plus 21 because it already has a denominator of x. And now I can flip. So x squared plus 6x minus 7 over x times, flip the second one, x over x squared plus 10x plus 21. So my x's will cancel, and now I need to see what these will factor into. Two numbers that when I multiply and get negative 7 and add to get 6 are positive 7 and negative 1. And down here, two numbers that when I multiply to get 21 and add to get 10 are 7 and 3. So x plus 7, x plus 3. And therefore they have both an x plus 7 on top and bottom. So they cancel. I'm left with x minus 1 on top and x plus 3 on the bottom. Okay, moving on to 11 and 12. Number 11. I leave the bottom alone for now. That one's fine, but I need to combine on top. So I'm multiplied by the opposite denominator, x minus 4 over x minus 4. This one, x minus 2 over x minus 2. Distribute the 2 to the x and the negative 4. Distribute the 1 to the x and the minus 2. I get 2x minus 8 plus x minus 2. Common denominator, x minus 2, x minus 4. Over. We can go ahead and factor this bottom fraction, bottom of the bottom fraction. Two numbers that when I multiply to get positive 8 and add to get negative 6 are negative 2 and negative 4. And now I can change this into a multiplication problem, combine terms on top. So 2x plus x is 3x, minus 10, x minus 2, x minus 4. Turn it into multiplication, flip this bottom fraction, x minus 2, x minus 4, and the 5 here. Notice that they both cancel out, and I'm just left with 3x minus 10 over 5. And number 12, there's nothing I have to do first. I can change this right into a multiplication. So x squared minus 2x minus 3, x squared plus 6x plus 5, times, flip the bottom fraction, 2x plus 6, and x squared minus 9. Now I need to factor all of these and see if there's anything to cross out. So x and x, minus 3 plus 1, x and x, plus 5 plus 1, take out a 2 here, and this is a difference of squares, so x plus 3, x minus 3. So what do they have the same on the top and bottom? They have an x plus 3, they have an x plus 1. What am I left with? I'm left with a 2 and an x minus 3 on top. And, I'm sorry, yeah, an x minus, oops, I can cancel my x minus 3's. No, I'm not left with that. I can erase that. I'm left with a 2 on the top and an x plus 5 on the bottom. So 2 over x plus 5 is my final answer. Alright. I think I'm just going to go ahead and finish up number 13 and 14 in the same video since it follows with complex fractions. And then I'll do another video for solving equations. Number 13 is the same way as the last one, I just have to flip it. So x minus 2, x plus 2 is the top fraction, times, flip the bottom fraction, 3x plus 6, and x minus 2. Notice there's an x minus 2 on the top and bottom. If I factor out a 3 from this, I'm left with an x plus 2. Those cancel, therefore I'm just left with 3. Okay, number 14. Remember, I can write the 3 times x to the negative 1 as 3 over x plus 4. And then 3 minus, again, x to the negative 1 I can write as 4 over x. So now I need to get a common denominator, which multiply x over x, multiply x over x, which means now you have 3 plus 4x over x. And down here you have 3x minus 4 over x. Flip them. So 3 plus 4x over x times x over 3x minus 4. X's cancel. 3 plus 4x is different than 3x minus 4. So therefore, I leave that as my answer. Alright, see my final video for solving equations.